Download this code from codegive.com, link in the description below. Certainly. Vector databases are specialized databases designed to store and retrieve high-dimensional vectors effectively. They are particularly useful for applications involving machine learning, natural language processing, image recognition, and recommendation systems. These databases can efficiently perform operations like similarity search, which is fundamental for tasks such as finding similar items, clustering, and classification. What is a vector? A vector is essentially an array of numbers that can represent various types of data, such as text embeddings from NLP models, image features from computer vision models, or user interaction data. For example, a sentence can be transformed into a vector using models like Word2Vec, Glove, or BERT. Why use vector databases? 1. High-dimensional data handling *. They are optimized for storing and querying high-dimensional data. 2. Fast similarity search *. They allow for quick retrieval of similar vectors using algorithms like approximate nearest neighbors, and 3. Scalability *. Vector databases can handle large datasets efficiently. Popular vector databases: FAIS, Facebook AI Similarity Search; Pinecone, Weaviate, Milvus. Elasticsearch with vector search capabilities. Getting started with a vector database, example with FAIS. In this tutorial, we'll use FAIS, a popular library for efficient similarity search and clustering of dense vectors. Prerequisites: you need to have Python installed with the following packages. Step 1. Create sample data. Let's generate some random vectors to simulate our data. For this example, we'll create 1000 vectors, each of 128 dimensions. Step 2. Build the FAIS index. We will create an index that can store our vectors and allow for efficient similarity searches. Step 3. Querying the index. Now, let's query the index to find the nearest neighbors of a random vector. Step 4. Interpreting the results. Indices of nearest neighbors *. This array contains the indices of the nearest vectors in the original dataset. Distances to nearest neighbors *. This array contains the distances to those nearest vectors, where smaller values indicate closer similarity. Conclusion: this tutorial provided an introduction to vector databases using FAIS. We learned how to create a random dataset of vectors, build a FAIS index, and perform similarity searches. Vector databases like FAIS are powerful tools for applications that require efficient handling of high-dimensional data. Further reading: FAIS documentation, https://faiss.ai. Pinecone documentation, https://www.pinecone.io. Weaviate documentation, https://we68.io. Feel free to explore these resources to understand more about vector databases and their applications. Vector databases, an informative tutorial. Vector databases are specialized databases designed to handle high-dimensional vector data efficiently. These databases are particularly useful in applications like machine learning, natural language processing, image recognition, and recommendation systems where data is often represented as vectors, example embeddings. Key concepts: 1. Vectors. In mathematics, a vector is an array of numbers. In the context of databases, vectors typically represent data points in a high-dimensional space. 2. Embeddings. These are low-dimensional representations of data, example words, images, that capture semantic meaning. 3. Similarity search. Vector databases excel at finding similar vectors, often using distance metrics like Euclidean distance, cosine similarity, or dot product. For indexing, efficient storage and retrieval of vectors often require specialized indexing techniques, example KD trees, ball trees, or approximate nearest neighbor, and algorithms. Popular vector databases. 1. FAIS, a library developed by Facebook for efficient similarity search and clustering of dense vectors. 2. Pinecone, a fully managed vector database for machine learning applications. 3. Weaviate, an open-source vector search engine that allows you to search through high-dimensional data. 4. Milvus, an open-source vector database designed for large-scale similarity search. Code example using FAIS. Let's walk through a simple example using FAIS to create a vector database and perform similarity searches. Step 1. Install FAIS. You can install FAIS via pip. If you have a GPU and want to use it, you can install the GPU version. Step 2. Import libraries. Step 3. Create sample data. Let's create some random data points to use as our vectors. Step 4. Build the FAIS index. We'll use a simple index for this example. FAIS provides several indexing strategies, but for simplicity, we will use a flat, brute force, index. Step 5. Perform a similarity search. Now, let's create a query vector and find the most similar vectors in our index. Explanation of code. Generating random vectors, we create 1000 random vectors of dimensionality 128. Building the index, we create a flat index using L2 distance and add our vectors to the index. Searching, we then generate a random query vector and search for the top 5 nearest neighbors in our index. The search method returns the distances to the nearest neighbors and their corresponding indices. Conclusion. Vector databases like FAIS provide an efficient way to store and query high-dimensional vector data. They are invaluable for applications that rely on similarity search, such as recommendation systems or image retrieval. As you build more complex models, you may want to explore more advanced indexing strategies and additional features provided by vector databases. Further reading. FAIS documentation, https://faiss.ai. Milvus documentation, https://milvus.io. Weaviate documentation, https://we68.io. Feel free to experiment with the code above and explore other vector databases to find the one that best fits your needs.